Good evening, sir. This is Dilip Dhanraj Rathod, and my topic name is pleasure application, and subtopic name is Raman spectroscopy. And we let's start with introduction. In introduction, Raman spectroscopy was discovered by C.V. Raman in 1928. It is the spectroscopic technique used to observe vibration, rotation, and other low frequency modes in a system. Raman spectroscopy is commonly used in chemistry to provide a fingerprint by which molecule can be identified. When the radiation passes through the transparent medium, the species present scatter a fraction of the beam in all directions. The difference in wavelength in between the incident and scatter visible radiation correspond to wavelength in the mid-infrared region. And we have another topic and principle of Raman spectroscopy. Uh, in principle, Raman spectroscopy is based on the scattering. The sample is irradiated, irradiated with a coherent source, typically a laser. Most of the radiation in, elastic scatter called the resonant scatter. A small portion in inelastic scatter. Raman scatter composed of the stocks and anti-stock portion. The latter portion is what we are particularly interested in because it contains the information in which we are interested. And let's change the slide. In Raman spectrometers, we have also some diagram like light passes through a simple sample and then the macroscopic active and we then final we will get laser and we have another we are done this and we have a differentiation between the Raman and infrared. In Raman, what is Raman? It is due to the scattering of the light by the vibrating molecule, and the infrared it is the result of the absorption of the light by vibration molecule. And water can be used as a solvent, and water cannot be used to due to its intense observation of infrared. In Raman, cost of the instrumentation is very high compared to the infrared. Infrared is very inexpensive. Infrared is cheap too, and different types of the spectroscopy. We have four types, and first we have resonance Raman spectroscopy, then surface enhanced Raman spectroscopy, macro Raman spectroscopy, and non-linear Raman spectroscopy technique. Let's slide. And surface enhanced Raman spectrometry. We have some diagram. Let's see, and you can see some. And we have in lone linear Raman spectrometry. We have another some graphs. Some are pie chart. Some are and Fourier transfer Raman spectrometry. There are few font. And finally, we have a conclusion. Conclusion in Raman spectroscopy is a valid measure to assess skin carotenoid status in situ from humans. RS accurately predict blood serum total carotenoids independent of demographic and lifestyle factor. And skin carotenoids are more stable over time than serum carotenoid, likely because they are not confounded by recent dietary intake. RS appear to be a better indicator of carotenoid status than blood carotenoid. And sir, finally we have my name is Dilip Dhanraj. I'm from the section A student. And sir, thank you.